Boom. How many intersections do these two graphs have? Okay, let's talk about that because that is a very big topic, especially earlier on in math methods in year 12. Okay, so let's talk about this. Let's say if I had two equations, one was x plus 5. What kind of equation is that, by the way? What kind of function is it? It's a linear graph. Yes, you got it. You're on a roll. Okay, next, y equals, I should write f of x and g of x, but yeah, whatever. Let's say x squared, stuff that. X plus 4 bracket squared minus 7, for example, okay, so we have a parabola, we have a linear graph. Now, here's my question, how many intersections do they have? Well, how would you figure that out? Simultaneous equations, that's exactly what it's for, right? Finding how many solutions and what they are to solve two equations in one go. But in this case, what you can do is, since y equals this and y equals that, we can just equate the two equations together. So let me get the good old black pen. All right, let's do this. X plus 5 equals x plus 4 brackets squared minus 7. So equate them. And then any smart person will go, let's solve that. You can use the solve function, which is the smartest thing ever. Like the solve function on your calculator, it's the best thing since sliced bread isn't that cool. Best thing since the bicycle. Right, what was I saying? I was saying solving that solve function, can do it on the calculator very, very quickly. But if you're like me, someone who's old school and is like, nah, let's not do the solve function. I could do it faster than you by hand, quicker than you can do it on the calculator. Follow me at home and let's get this solved somehow, okay? Because I truly believe, and there's also a non-calc exam in methods, right? So there's a big gift in doing things without the calculator and forming that habit from earlier on, and especially now, so that you can actually solve things quickly for that non-calc exam. Sometimes you can even do it quicker, without the calculator than the calculator. So it's a valuable gift. I do recommend it highly. So to do this, we're going to expand that, take everything on one side, equate to 0, and then solve for that quadratic somehow. Okay, we'll figure it out as we go along. So let's do it at home. Do it with me. Okay, expand that. X squared plus 8x plus 16 minus 7. You know what? Just rub that out. Minus 7, that's plus 9. Boom, right? On the other side, let's chuck everything over. Minus x minus 5. You knew that, right? It's easy stuff, prep stuff. Okay, that's a 0, by the way. So we got x squared plus 7x plus 4. Okay, cool. That's the quadratic we have, equal to 0. Now, quadratics, how do we solve that? We can use the factorized function on the calculator, we can solve it on the calculator, it doesn't matter. But by hand, okay, here's what I do. And I'm the best, so I know exactly what to do, right? So the first thing I do is I give it the good old 3-second rule. If I can't factorize that into two neat brackets in 3 seconds, then I go to plan B. What's plan B? You know plan B. Everyone knows plan B. Quadratic formula. We know it, right? Quadratic formula. You know the big one. Yes, exactly. The quadratic formula. Everyone knows the quadratic formula. I have it even tattooed on my butt. It's that important, okay? You have it tattooed on your butt too, and then you'll remember it. It's negative b plus minus square root of b squared minus 4ac over 2a, right? Write that down if you don't know it. So, I look at it, I can't factorize it, quadratic formula straight away, and then instantly I'll get the solutions. By the way, will there be any x-intercepts or any solutions? How would you know? The discriminant, the part under the square root, right? Under the square root. Now, just by looking at this, I know that there's not going to be any solutions. Why? Because of the plus 1. I'm not going to go into it, but I just know that there won't be any because b squared minus 4ac ain't going to give you a positive answer. It's going to be negative. Okay, so that aside, there won't be any intersections between these two graphs. They won't intersect. Okay, it's one of those cases. It's one of those, I'm here, we're not going to touch. All right, so the next situation, the next type of question I want to go through is when they're both linear graphs. And this has come up again and again over the last 5 years in methods a lot. I mean, to my surprise, because, come on, linear graphs here. Not meant to be that hard. So these questions are more to do with like y equals, I'll give you a simpler version. Maybe I will, maybe I won't. Let's say this. Okay, I'll give you an easy version. 3x plus 7, y equals negative 2x minus 9, for example. Okay, so I just want to talk about the theory for now. So, first of all, they're both linear graphs. Are they ever going to hit? Well, yes, if, right? Yes, if the gradients are not the same. So there are a few different situations that we can have here. Okay, so let's talk about this. If the gradients are not the same, they will always meet somewhere. They will always rendezvous somewhere. Okay, if the gradients are not the same. So this is called the unique solution. Good old unique solution. That means there's one unique solution. Doesn't that make you feel all nice inside or special? Unique solution. Okay, case number 2. If they have the same gradient. Let's say if that changed to positive 3, they have the same gradient. What happens then? Okay, well, 2 things could happen. They could be absolutely parallel like this and therefore have no solutions, or they could actually be very naughty and be on top of each other. Right, that's the case that we're all looking for, right? On top of each other. And how many solutions would that yield you? That would yield you infinite number of solutions. I'm not going to write that down. Infinite number of solutions. So there's 3 outcomes. There's unique solution, no solution, and infinite number of solutions. And it all depends on, first of all, whether the gradients are the same or not. And then if they are the same, then there's 2 possibilities. Whether they have different y-intercepts or if they have the same y-intercept. If they have the same y-intercept, they're on top of each other, they have infinite number of solutions. If they are not if they're not the same, then they're not going to have a solution whatsoever. So those 3 outcomes of how many intersections will I have, that's very important. It's a very important concept to know. And if you look in checkpoints, I think it's in A1, there are a lot of these types of questions. That you got to get familiar with, because it's all about, okay, I know there's a couple of ways to do this, and most of the time I think teachers would try and teach you via the matrices way, but I think matrices are totally gay. So if you can do it via this particular way and understand it, then matrices seem so easy. So I want you to go through those questions. There's at least 4 or 5 of them in the first chapter of checkpoints. Get them done. This is an important concept, especially for that first sack in methods that you're going to face, Michi. You're going to have that very soon. How are you going to cope with that sack, right? Remember, we have a cash bet. You're going to win some money if you can beat Bosco, but you got to beat him. You got to beat him convincingly. And don't let that Serbian beat you, because he's from Serbia, and you're much better than that, right? No offense, Bosco. Alright, so this is the concept. Get your head around it, do those checkpoint questions, and make sure you check the answers, make sure that you're correct with the answers, make sure you know exactly what you're doing. And I'll talk to you soon.